Hi friends, let's have a look at problem 1202, smallest string with swaps. So actually this can be regarded as a follow-up for problem 2948, which we just finished. So here we are given a string and we are given a list of pairs. So each pair basically contains two indices, which means that you can switch them. So here you can swap the characters at any pair of indices in the given pairs any number of times. So here we want to return the lexicographically smallest string that s can be changed to after using the swaps. So if you look at the examples, let's look at example 1. So because index 0 and index 3 can be swapped, so we can put b in front of d, right? So we have b, c, a, d. And also index 1 and 2 can be swapped, so we can put a in front of c. So basically we get b, a, c, d, right? That's the example 1. In example 2, actually, if you look at this one, so 0 and position 0 and 3 can be swapped. But position 0 can also be swapped with 2. So, and 2 can be swapped with 1. So actually 0, 1, 2, 3, they form a connected component. So you can swap as you like for any two indices in between. So therefore, we just need to sort the array. So we get A, B, C, D. So in other words, so here we just need to find the connected component corresponding to the graph established by the pairs. So within each connected component or cluster, the corresponding characters can be put in sorted order. So that's actually the whole logic for the problem. So here you can also see the problem size, and also S contains only lower English letters. So with that said, I guess we are ready to do some coding. So here the key thing is to find the clusters of the indices or the connected components. So basically there are two ways to do this. So one is you use graph traversal. So for example, BFS or DFS, or you use union find. So this is also called disjoint union data structure, disjoint set data structure, right? So here I'm going to use this one. Actually, I found that I had a previous video which solved this problem using union find, but I wrote that union find as a disjoint set data structure in a separate class. But here I'm going to write some function within the main method or solution method here. So with that said, let me carry out this program. First, we're going to implement find method and then union method, and then we are going to assign class names similar to this the video for this problem, and then we do the assignment. So first step, so we get the length of this string. So this is the very standard, right? So now I'm going to have two dictionaries. So roots, so for I in range n. Originally we assign the root of a index to be itself, and then the rex. So I'm going to assign it originally to be 1 for I in range n, right? So these two lines are very easy to understand. So this is our initial states of the roots and the rex before we consider the relations encoded by the pairs list. So now let me implement a very common method called find, right? So here basically let's call result find. Let's call result I equals I, right? So while roots result does not equal to result, so then we are going to basically set result to be roots result, and then we are going to return result. So because after this while loop, we get roots result must be result itself, right? In other words, we retrieve up to the root or the name of that cluster. So typically you can add one more line. So let me copy this line here, and then I apply roots here. We assign the result, the roots of the result, to be the roots of the roots of result. So this is the so-called path compression. So this actually brings some performance gain. For this problem, we add here, but you can choose to ignore this line. So this is the one. And then also we can define union. So here we also have two options, like the vanilla union and also the union by rack, because here we initialize a rack's dictionary. So we're going to implement union. Let's see, union by rack. So here actually what I implemented is let's see, font with path compression, right? So here union by rack. Let's put it here to make it a little bit better. So now let me implement this one. First, I find the root. So find I, find J. In other words, we check if I and J are in the same cluster. If they are in the same cluster, we do nothing. Otherwise, we just join the corresponding clusters. So if root I does not equal to root J, then we are going to do join. So in the vanilla union, so you just need to do this. Root J to be root I. That's it. That's it for the function. But here, in order to gain some performance, so we are going to check by racks. So if, in other words, we join the smaller one to the larger one. So if root I, racks of root I is greater than or equal to racks root J. So in this case, I'm going to assign the root J to be root I. In other words, merge the smaller one to the larger one. Then the racks of root I is incremented by the racks of root J. So this is the one case. Another case, we just need to copy this two lines and change the name. So we merge the smaller one to the larger one, and then the racks of the larger one will be incremented by the one of the smaller one. Racks of right. So that's it for the union. So also for this problem, I want to get the clusters. Let me define a get clusters function. So basically, I have a dictionary, and then I'm going to iterate. So for I and R in roots items. So this I is the index, and R is the corresponding group or cluster name. So I want to find the root of R, right? So root of R will be roots, not roots, find R. And then what I'm going to do is, if root R not in D, so I'm going to do D root R assign as a set containing the current index. Otherwise, I'm going to do root R, because it's a set, I'm going to add the current index. So then we just need to return this D. So actually you can print out this D later. So for now, I guess we can look at the problem logic. Above are some preparations. So basically we have initialized two variables, roots and racks. And then we implement three methods. The major ones are find and union, and a hyperfunction called getClusters. So up to now, we haven't used the problem assumptions yet. So now let's look at the problem assumptions. So basically for ij in pairs, so we just union them, right? That's the problem logic. So now let's see, after we do these operations, what's the state of the clusters? So let me call clusters So get clusters. Let's print out this one, clusters. So for the first example, we have 0, 3. So they belong to the same cluster. I name it 0. And 1, 2 belongs to another one. I name it 1. So if you look at the second one, because all of them are connected, so we have all 3 indices. They belong to the same cluster. Let's name it 0. For the third one, the same thing. So we name it also 0. So with this preparation, let me delete this one. I guess we can do the assignment, right? So you can do exactly the same as problem 2948, but also you can do some inner sort. Let me do some sort because this is a little bit fast. So result, so let me use this none and length n. So I can determine the character for each index, then I just need to join the result. So for cluster in clusters values. So here we focus on the because if we call this each one, actually we distinguish each one. We will focus on the indices. So first we get indices will be sorted cluster, right? Then from small to large, because we want to find the lexicographically smallest one, we first associate the smaller index with the smaller character, right? So the characters, we can also sort it. So sorted. So the character will be SI for I in indices, right? So you can also use for I in clusters. It does not matter because we use sorted, right? So then we just need to match the indices and the characters. So that's very easy. We can be easily done for I and the character in zip, right? Indices and characters. Then what we are going to do is result I equals sign to be character, right? So now we just need to return. So for return, we just join, right? So that's it for the full coding. Now let me do a test. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's basically about it. Let me give you a quick summary of the video. So here, our goal is to find connected components or clusters of the graph given by the pairs list. So typically, to find the clusters or connected component of a graph, we have 2 groups of ideas or methods. One is graph traversal. The other is union find. So the corresponding data structure is called disjoint set. So here, actually, I didn't use a class to implement this one. I used some method. So we implement the find union key methods for the union find method. And then also I implement a get clusters hyperfunction. So with that said, we consider the problem logic. And then after we do the clusters, then we assign the corresponding index with the correct character. Then we return the result by using join method. So with that said, I guess that's all about it for the current video. Thank you for watching.